Hi guys, I wanted to give an update on the Simplest VGA plus BE6502 project. So last time round I think I had just about decided to drive the CPU from the video clock instead of trying to make them asynchronous. At least temporarily I'll do it that way. It's more reliable, and once you get the timings right, it's more reliable and it's very fast. So that's currently how this is working, and I'm using 6.3 MHz as the CPU clock, which is a quarter of the VGA pixel clock at 25.175 MHz. So that's all over here. It's a bit of a mess at the moment. I need to tidy that up, and that's one of the next things I'll do, is sort of take out the bits that aren't being used and tidy up the wiring for the bits that are being used. It'll condense it down quite nicely. So one of the problems that I had in the last video was that I still had quite anisotropic pixels, meaning that the pixels were much wider than they are deep. I had 40 pixels across the screen and 480 pixels up the screen. And usually what you do this is partly because of the amount of memory it would take otherwise. I wanted it to all fit within 32K of video RAM, and usually the way you deal with that is by double scanning and showing every line of pixels twice or even 4 times. But that wasn't really easy for me to implement, because the way the Simplest VGA project works, it doesn't have separate vertical and horizontal counters, so it's not trivial to replay a line of pixels. So in order to make that work, I have actually had to separate those counters out and have the horizontal counter being independently reset and so on, and I've sacrificed one of the color bits for that. So now my memory format has 4 bits of control data and 4 bits of color data. But having done that, I've been able to quadruple scan the screen here. This is also using the 640 by 400 video mode. And again, that's partly because of memory reasons. After separating the counters, I had to pad it out horizontally as well, which wasted a ton more memory. So this is what you can fit in 32K now. So this is quadruple scanning vertically, and also horizontally all the pixels are 4 times wider than the 640 VGA should be. So this is 160 by 100 resolution. Which is blocky, but I think it's actually quite a nice resolution as a sort of an entry level getting VGA into your 6502 kind of thing. It's you're not getting crisp text out of that, but you are. It's very fast to update because it's one byte per pixel. Very easy to write the code, and yeah, it's pretty fast because one write for the CPU affects a big block on the screen. So yeah. Works quite well. This Pong thing is nowhere near stretching the CPU. I had to slow it down hugely for this. I've synchronized it to half the frame rate, in fact. So the I could show you a different program. Let's do that. This is just going back to my test program. So I can put that in there. Done. Work that back in here. So this is the test program that I had in the last video with some changes since then. So you can see that colour rainbow I showed last time round is really small now. But this is a 16 colour mode. I've got 4 bits per pixel here. That colour palette's a bit weird. It's 2 bits of green and 1 bit of red and 1 bit of blue. I'll probably change that to be more like the standard VGA palette because it's easier to use that one. I also found this maze thing online, and I had a little experiment with monochrome output using shift registers and things like that, and that's kind of what this maze was designed for. However, I've kept the data, but I'm rendering it as colours, and it doesn't work at all, obviously. But yeah, that's just listing an image to the screen. That's pretty fast as well, the way it draws it, because again, it's only 1 pixel, but 1 byte per pixel, and it sort of fills a big block on the screen. And then, yeah, I just made this sort of random pixel plotting thing to partly to check out the random number generator and make sure that was working. But yeah, that's that. And as you saw before, I started making a Pong game, but I got a bit bored of that and decided to do something else instead. So let's whack the EEPROM back in the programmer. So instead of that, I made a snake game. And I've hooked some buttons up down here as well. Yeah, so I just saw the blocky pixels and thought this was a really good fit for it, so yeah. I also saw someone else's YouTube video from a few years ago on a FPGA CPU playing Snake, so I thought I'd do something similar. Sorry, my phone's really struggling to focus on this. So you can see on in this corner of the screen, actually, while we head over for this apple, these little artifacts at the side there, and those are due to the way I separated the counters for horizontal and vertical indexing. The vertical counter is a really slow 4040 VE ripple counter. I did that because I needed lots of bits for the vertical, because although I'm only displaying 100 pixels vertically, I do need to count up to the full 489 for this video mode. Was it 449 actually, I think. And I just ignore the bottom few bits of the vertical counter. And because of that, I didn't want to. I couldn't fit it all in an 8-bit counter, and I didn't want to use 2 chips. But that didn't really work out very well. The side of the screen over there is corrupted for that reason. So I probably will swap those for a 4-bit and an 8-bit counter working together instead of one 12-bit counter, and it should get rid of that. Because the 8-bit counters I'm using are synchronous, and so are the 4-bit ones. So yeah, it'll just work better. Anyway, this is where I am with this at the moment. I think what I'm planning to do is tidy up the circuit, which has got a load of wires hanging out of it at the moment because of all the random hacking I've been doing to it, and make a new schematic for that. And then I might make a separate Hackaday project for this specific version. The other Hackaday project covers the ROM version of it, which is sort of minimally what can you put on a breadboard to get a VGA output signal. But I think it might be useful to have a separate documentation for how to add this to a Benita CPU. Sorry, a Benita 6502. But yeah, that's it. That's where I'm at, and hope you enjoyed the update. And I'll say some more soon. Let me know in the comments if you've got any questions about any of the changes I've made here, or yeah, if you're building anything like this yourself, or if you want to copy this one, let me know, and I can provide the schematics.